There are three properties of logarithms and a change of base formula that are useful. The three properties come from the rules of exponents, actually, and here they are. We have to say that b is greater than 0 and b does not equal 1. That's our basic rule for logarithms. The bases cannot have to be positive and cannot equal 1. And m, they can be variables, they can be numbers, they can be whatever, as long as they're positive, because a logarithm cannot have a negative or actually a 0 on the inside of a logarithm. As long as those conditions apply, then you can use these properties. The first one says m times n equals the log of the first plus the log of the second. This actually comes from the property that b to the power of, well, let's do it like this. Let's b to the power of m times b to the power of n is the same thing as b to the power of m plus n. That's the rule of exponent that comes from, but it's in logarithmic form. The next one is very similar. If we have a division, it goes to subtraction. So just keep in mind, multiplication goes to addition. Those two are very connected in a lot of ways in mathematics, just like division and subtraction are connected. Addition and multiplication, multiplication is just repeated addition, and division and subtraction are the inverses of multiplication and addition. So they're very connected, and that's the reason why you see them in properties like this. So division goes to subtraction, multiplication goes to addition, and this comes from the fact that b to the power of m over b to the power of n equals b to the power of m minus n. Same idea, it's just in a logarithmic form. Now the last one is really just a repeated use of the first one. M to some power n, you can actually, and this seems kind of weird, but you can actually take the number off of the power and put it in front. And just to give you a simple case of it, let's assume we have log base 2 of x squared. Well, this is the same thing as log base 2 of x times x. And from the first property here, if we have a multiplication, that leads to addition. So we have log base 2 of x plus log base 2 of x, but that's the same thing twice, so they're like terms. So we have 2 log base 2 of x. Essentially, I took the 2 and I brought it down front. That's how those two things there. And you can test this for like x cubed, x to the 4th power, x to the 18th, and you'll see that the number always comes out in front just because we have that many factors here in the addition. So there's the three rules of logarithms. Just cleaning up here a little bit. And we're going to be using these in some problems to simplify the logarithm down. So for the first problem, we have log base 5 of square root of x over 25. And for this problem, we want to expand this thing. So expand it as far as possible. So first off, I see that there's a division inside the logarithm. So I'm going to use property 2. The division goes to subtraction. So I have log base 5 of the top minus log base 5 of the bottom. And now I can do some work for the inside. I'm going to make these things, so for this one right here, I'm going to make the square root of x have a power instead of a square root. So that's going to be log base 5. The square root is the same thing as a 1/2 power. And then this 25 here, it's actually a power of 5. So I'm going to write it like that. Log base 5 of 5 squared. 5 squared is 25. And now I have an argument of a logarithm to some power. I can move the power out in front. And log base 5 of 5, those cancel, giving us just the power by itself. And you can see here, the logarithm has only one thing on the inside, so really we can't simplify this down any further. So this is completely expanded. and simplified. Okay, next one. All right. For this one, you do not see parentheses around the logarithm or around the argument of the logarithm. It's assumed that you understand that this entire thing is inside the logarithm. However, I don't like that kind of notation. I like making it completely explicit what I'm talking about, and so that's why I put parentheses around it. Like right here, you don't really need to put parentheses around the x, but if you didn't, then you could have something like this. And some people might accidentally interpret it as that, which is incorrect. That's the reason why I like to be very explicit and say the x is on the inside. Okay, so first off, this square root of 5 can be rewritten as 1/5 power. Now, the 1/5 is on the inside of the logarithm, and it's a power of everything on the inside. That means I can move it out in front, giving me 1/5 log base 2 xy to the 4th over 16. Now, I see there's a division here. I can open that up. Important to note that 1/5 or 1/2. 1/5 is multiplying everything here. It's going to be the top minus the bottom. And I see that this right here is a multiplication, which means I can split that up into addition. So 1/5 log base 2 of x plus log base 2 of y to the 4th minus log base 2 of 16. And actually 16 is the same thing as 2 to the power of 4. I'm going to rewrite that as 2 to the power of 4. Save a step. Okay, here I have a power that I can move out in front, so I'm just going to bring the 4 out. And the log base 2 and the 2 cancel, giving me just 4 there. 4 times log base 2 of y minus just 4. And you can distribute the 1/5 in there. I don't know if that's any simpler, but maybe that's what they want in your homework. 4 times 1/5 is 4/5. And again, 4/5. And that's completely expanded. You see in both logarithms, there's only one single thing, x and y. And I can't do anything else in there. That's completely expanded. So I'm just using these properties, right? I'm just using multiplication. Again, multiplication goes to addition, division goes to subtraction, and we can move the power in front. Those are the properties that we're using there. Okay. Now, so what I've done in these two problems was expand them. The next problems I want to condense into a single logarithm. So let's say we have 7 times the natural log of x minus 3 times the natural log of y. Ln of x, ln just stands for log base e. But ln is shorthand for it since it's used so frequently that we have a simpler way of writing it. Now, one thing I can do here is that there's a number in front, which means I can put it to the top in the powers. So I have ln to the 7th minus ln y to the 3rd. And here I have two logarithms that have the same base and they're subtracting each other, which means I can combine them by dividing the interiors. And that's completely condensed. It's got a single logarithm in the final answer. That's our answer right there. Okay, another one that we want to condense This one's a longer one. Log of 15 minus log of x plus 2. So note here that logarithm does not have any base written, and if a logarithm doesn't have any base written, that's assumed to be log base 10. Okay. So I have an addition here. I'm going to take a step by step. So I'm going to do the first two. That's an addition, so I can multiply the interiors. X times x squared minus 4. And then here I have two logarithms of the same base that are subtracting, so I divide. Minus log x plus 2. And once again, I have subtraction, so I'm going to divide again. And just as a side note here, if we divide this by x plus 2, that's the same thing as multiplication by the reciprocal, which is the reciprocal of x plus 1 over 1 is just 1 over x plus 2. And all it really means is that you're multiplying the denominators. 15 times x plus 2. So our logarithm should look like this. Keep that in mind whenever you're dividing a fraction by something, by a single number or some expression. All you really have to do there is multiply the denominators. Okay, now this is condensed. We have only a single logarithm. However, we can simplify this further. Namely, x squared minus 4 is a difference of two squares. So x squared minus 4 can be factored into x plus 2, x minus 2. So we have x plus 2, x minus 2, over 15, x plus 2. And now we can cancel the x plus 2. And this is simplified. Really briefly, I want to go over some of the caveats with this problem here. All logarithm problems, you have to concern yourself about the domain. And for this one, we need to also say which values of x are not allowed in our domain. You always need to think about that kind of thing when you're dealing with functions. So to look at the first problem, this is the function we started with. And then this is what we got when we simplified it or condensed it and everything. These should have the same domain. And we can see that by looking at this top one, log base of x. This means x must be greater than 0 because the inside of a logarithm cannot be 0 or negative, which means x must be greater than 0. Now for the second part, log of x squared minus 4. X squared minus 4 must be greater than 0. But if we add 2, we get x squared greater than, I'm sorry, not 2, add 4. We get x squared greater than 4. And when is that the case? That's when x is less than negative 2 and x is greater than 2. That's because when we have negative 3, for instance, negative 3 squared is 9. So the squaring actually gets rid of the negative for you. So we have these two kind of statements that we have to consider. However, x is greater than 0, and this one says x is less than negative 2. That one must be excluded because we have this stipulation saying x greater than 0. And so now we have x must be greater than 2. That's the new kind of most restrictive domain. Okay, log base 15, that's just a number. You can actually type that into a calculator and solve it. And then log x plus 2. This is x plus 2 must be greater than 0. Again, it always has to be greater than 0. And then subtract 2, x must be greater than negative 2. But if x is greater than 2, then x is already going to be greater than -2. So we know our domain must be x greater than 2. Now, during the problem, I'll actually go over to it here. During the problem, we had this statement here in the denominator here. We need to make sure we don't have a division by 0, which means, that's what I have written here, x cannot be equal to -2. That gives a 0 in the denominator. So we have to exclude that also from the domain. However, if x cannot equal -2 and x must be greater than 2, that already satisfies it. So our final domain for this whole problem is x must be greater than 2. That's the only way we can plug things into this logarithm and still have this original function work. So keep that in mind. Whenever you're dealing with functions, you need to really analyze the denominators. Sorry, the domains. The denominators are part of that. But each function has restrictions that you have to consider, and then just follow that through all the way throughout the problem. Okay, the last property we're going to talk about of logs is the change of base formula. Change of base formula. So all this does is it goes from one base to another base. It's not necessarily all that useful. We do have calculators that can, solve logarithms with any base. Back in the day, it was more of a thing. But you never know if you're going to be wanting to change the base, and you can do some simplification with that when you're doing the algebra. So a change of base formula works like this. Let's say we have some base with something on the inside, some expression, something, and of course the normal rules applies. B is greater than 0, and b cannot equal 1. M is also greater than 0. To change the base to a different base, we take the logarithm of the new base, a, of the inside, and the logarithm of the new base of the old base. Think of it like this, right? If you draw a line here, m is on top, so m goes on top, and b is on the bottom, so b goes on the bottom. And then the new base is what you're going to be using for this right-hand side. So what base do you change it to? It can be whatever you want. A lot of the times context will dictate, but I will tell you that probably you're going to be changing it into either ln or log. The natural log and the log base 10 are the most useful logarithms. So that's probably what you're going to be changing them into. But sometimes you'll want to have, log base 2, log base 5, log base whatever, depending on your context. So let's say we had log base pi of 63. I'm going to change this into the natural log. So natural log, right? I said this before. Natural log is log base e. Log is log base 10. It's just shorthand notation. The inside is on top, and the base is on bottom. And now this is, the new logarithm. I've changed the base from log base pi to log base e. Likewise, log base 0.3 of 19 changes to log base 10, the inside on top, and the base on bottom. And so now I have a logarithm base 10 instead of log base 0.3. And that's how you use the properties of logarithms.